Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Hafizuddin bin Tekun Ashraf. So this is my FYP. I designed a 4-wheel smart robot car with steering. So this is it. I designed a smart robot car with 4 wheels and it can control the steering. So from we can see here, each of the wheel has motor, means that we can control each of tire. For example here, as we can see in the video, we can also make the car turn even without using its steering by giving different speed at its different side. For example, like this video, I give higher speed for its right side and low speed for its left side. That's why, as we can see in the video, this car can turn left. As usual, we can also make the car turn by using its steering. So to calculate the speed of the robot car wheels, here for example, we want to make the robot car move straight with a length of 179 cm. We can use this formula. Distance divided by time, we get the speed. And also this formula to get the omega speed, we divide by the radius of the wheel. And from the diagram here, we assume IARA very small, so that's why here VA approximate to EA. So from this information we get from the datasheet, with this formula EA equal to K omega, thus we can conclude K approximate to 41. Using this value, we can convert any RPM value into voltage. So here we already calculate 4.087 volt. So we divide by the voltage supplied by the battery, which is here we see 7.4 volt, and we multiply by 255 to get the value in analog. But here we can see I minus one side of the robot car by 0.2 volt and the other side I plus 0.4 volt. This is because there are voltage drop and also extra voltage within the motor driver. And here also you can see I didn't divide by 7.4 but I divide by 7.6. This is because I just measure voltage supplied by the battery to the motor driver 7.6, not 7.4, because I just charge this battery. So we get this value. Here is the coding. You can see here I already put the value that we just calculate. So yeah, let's see the result. So supposedly this car will only move until here. So let's see the result. So next is to make the robot car move semicircle. These are the calculation to make this robot car to move as shown in the picture. This calculation is already correct, but it's not applicable with the car because this car has 4 wheels. If we want to make 4 wheels car to turn, we need to use steering. If not, they will have bigger slip if we try to do the same concept with a 4-wheel car. But these calculations are already correct. It is applicable if this car have only 2 wheels. So this is what I mean. I replace both of the robot car tire with this round ball so that it will have no more slip. So to prove this, here you can see that I already calculate. So this is the calculation. So here you can see 5 volt for the one side and 3.704 volt for the other side. As you can see here, I minus 0.6 volt for this side and plus 1 volt for the other side. Then we can convert into the analog. So here is the value. So this is the coding. Here you can see I already put its value. So this is the time 1.92 seconds. Let's see the result. Now you see that the car only move until here, right? Not until the end. This is because there's still slip because of the floor. So what I do is I add a rubber band for each of the tire, which is we can see in the next video. Here I add rubber band for each of the tire, so we see how was the result. As you can see here, it successfully reached until the end. So next we are going to calculate speed of the robot car when it includes with steering. So when it includes with steering, there's limitation in the calculation because try to think about it. If we turn the steering into some angle, of course its starting point will be show like this figure B. So it will be hard for us to calculate its radius. We cannot make the calculation as we doing before. So solution is I make a manual experiment where I move the car using my hand. While I moving the car, I calculate the number of rotation of the wheel. So these are the result. For example here, for 120 degree, if we want to make diameter around 86.65 centimeter, we need to turn from left wheel and rear left wheel 8 times, and from right wheel and rear right wheel 6 times. So these are the calculation. We get this value in analog, 129.223 and 172.297. So see here, these are the coding. We already set the angle to 120 degree, and these are the value that we already calculate. So let's see the result. So as we can see here, it not really reach at its endpoint. So this is because there's a big slip happen here. So for this car, I only made it move 90 degree, not semicircle, which is 180 degree. So as we can see here, this result is more accurate. This is because the less car travel, the less slip it has. So to fit this problem is we need to maybe add more time so that this car can reach. So that's all from me. Thank you.